Welcome back to this learning series on Rust. So far we've set up our Rust toolchain and we've covered the basic syntax. Now we're going to put it to work and build our first real program. We're going to build a rock, paper, scissors game and we'll play it against the computer. So essentially you type a move, the computer will then pick a move at random and we'll keep score as to who's won a particular round. We'll keep playing round after round until we type quit. Now this game is a really fun little exercise because it's building on 4 things that show up in almost every Rust program. So we're going to be learning how we can read input from the keyboard, we'll pull in external libraries, we're going to define our own types, and we're also going to do a bit of branching focusing on the match keyword. We'll build this in small pieces and run it after each piece so we can always see the code working before we move on to the next part. So the plan is we will read a line of input from the keyboard. We'll then add a library called rand to pick the computer's next move. We will describe the 3 moves with a type called an enum type. And then we will turn the player's text into one of those moves. And we'll decide the winner using a match. We'll then wrap it all in a loop that keeps score until the player types quit. So we're going to start as we will with every project, and that, if you can remember, is with cargo new. I'm going to call this rock, paper, scissors. That's going to go ahead and build my new program, and we'll cd into that. I'll just clear that, open that up. So I've got my main.rs file and also the cargo.toml file. So if we look into that Rust file, it's just going to print hello world. So let's make sure that everything is running correctly. Just type cargo run, and that's going to compile and produce hello world. So essentially what happened there, cargo compiled the starter code and ran it. And this is going to act as our safety net for the rest of the episode. So whenever something breaks, we'll run it and see exactly where it's broken. Okay, now let's start to write our game. If you haven't opened it already, make sure you've opened the main.rs file within the rock, paper, scissors project that we have just created. Now, the first thing we're going to look at is getting input from the keyboard. So to read from the keyboard, we need the input and output tools from the standard library. So we're going to bring them into scope with a use statement. And then I'm going to declare some variables. So when we type something in, that's going to save to a variable and we're going to print it out. So let's do that. All right, let's read this slowly because there's a lot packed into these few lines. So the string colon colon that we're doing here makes a new empty growable piece of text, and we're going to mark it as a mute. So it'll be a mutable variable, something that we can change. And the reason we're doing this is because we're about to let another function write into it. Now the IO_stdin, or standard input, gives us a handle to standard input, the stream of whatever the user types. The readLine method here, or function here, sorry, reads from one line from that stream and it's going to append it into our string. So essentially we're declaring a new string variable here and we've made it mutable so we can actually write into it. Now the part that trips people up is this ampersand mute input. Essentially what that ampersand means is that we are passing a reference, so a borrow of our string rather than the string itself. And mute means that the read line is allowed to change it. So essentially what we're doing here, we are lending our string to read line and saying, you may write into this. Now references are a whole topic within itself. I'm going to cover that in a later episode, so don't worry about the mechanics just yet. For now, just read the ampersand mute input as letting the readLine function fill in some input. And finally, that readLine function can actually fail. So it hands back a value that describes our success or failure. And expect it says, if it failed, stop the program and then print this message. So failed to read line here. You can put anything in there for your exception message, but essentially if something goes wrong, it's going to print that message. And then all we're doing within this program is typing in some input, and we're going to get a print of that saying you typed and whatever our input is. So I'm going to open up another terminal. I'll actually use the same terminal as I was before. That file is saved. So if I go cargo run, and I've already made a mistake because it's 2 colons, not 1. There we go. That's better. So let me try that again. They're just happy little accidents. Okay, so it's printed out rock, paper, scissors. So type a move or type quit to stop. I'm just going to type rock, and it's printed out you type rock. So essentially, notice that the echo text still has a line break on the end. So from when you press enter, which is why the output spills onto the next line, we'll trim that away when we turn the text into a move. But for now, just realize that we've used the standard input-output library to take some input from our keyboard and produce some output back to us as the user. So it's a pretty handy library to use. All right, now this library, it comes as part of Rust. So it's this part of the standard library of Rust. Now, as part of the standard library, Rust doesn't actually ship a random number generator, so we need to add one. This is what we call an external library. Now in Rust, external libraries are called crates, and the community publishes tens of thousands of crates through a registry, crates.io registry. So essentially we're going to pull one in using cargo. So what I'm going to do, just open up the cargo.toml file for this. So these are where our dependencies are gonna land. So they should be written underneath here. So if I open up the terminal a little bit more, I'm gonna go cargo add rand. That's going to install the rand crate for me. So if I look at my cargo.toml file, I can see that the rand crate has been brought in. So recording that our project, this toml file, remember, is our manifest for our application. So this cargo.toml file is now recording that our project uses rand and whichever version is acceptable. So the next time we build, cargo will download rand and anything else that it depends on, compile it once, and then links it to our program. From here on, adding a capability is often just a cargo add and whatever library you're going to use. We'll use rand in a moment to pick the computer's next move. Alright, so a move is one of exactly 3 things, either rock, paper, or scissors. And this is a perfect fit for an enum, which lets us define our own type by listing every value that it's allowed to be. So I'm going to open up my main.rs and just get a tiny bit more real estate here. And let's code the following. All right, let's unpack this. So an enum is just short for enumeration, and this essentially defines a new type by naming every value that it can hold. So our move type is always exactly one of rock, paper, or scissors, never anything else, and the compiler will hold us to that. This is one of Rust's most useful features. So instead of representing a move as a loose number or a string, we can give it a precise type. And that removes a whole category of mistakes for us, which is really powerful. Now the line above enum, starting with hash derive, asks the compiler to generate some standard behavior for us automatically. So debug allows us to print the value for inspection. Clone and copy lets us duplicate it and pass it around freely. And partial EQ lets us compare 2 moves with the double equals. Now these are called traits, and we'll cover traits properly in a later episode, but for now, read derived as just a request for convenient defaults. Now if we move down to the random move function, essentially it's going to ask rand for a whole number in the range from 0 up to, but not including 3. There's no equal sign here. So essentially it's going to return either 0, 1, or 2. And it's going to match each number to a particular move. Now notice the underscore here in the last arm. This acts as a catch-all, meaning everything else, which in this situation is just the number 2. Matches have to cover every possibility, and the underscore is how we say all remaining cases. Now, to make sure that this function is doing and rand is doing its job, let's go into our main function and type the following. And I'll open up my terminal again. I'll use the same terminal as before. And we are going to, just doing a bit of testing. Let's see if it actually works this time. So cargo run. And there we go. So your 5 will differ because they're random. So we're getting some warnings here because we're not using some standard library stuff and some variables, but that's fine. But the curly brace question mark is essentially the debug format that we just derived, which is why the 5 moves, let's just open up this terminal. That's why the 5 move names will print. So once you've seen it work, we can actually go ahead and delete this temporary loop, and we'll write the real main as we move on. Okay, so now let's turn the player's text into a move. So essentially what we're going to do now is convert what the player has typed into a move. Now, some input may not be a valid move. So essentially what we're going to do is return an option. So some move if we understood it, none if we did not. So let's go ahead, just underneath our random move function, write the following. All right, so 3 ideas are working together here. So first, option. So this function returns an option of move. So it's essentially Rust's way of saying that the result might be there or it might not be there. Now, sum wraps a real value. None means that there's nothing. So Rust has no null, so no silent missing value that explodes later. Instead, absence is a value that we have to handle on purpose, and option is that value. So any input that is not a move gives us none. Second is the cleanup. So trim removes the surrounding white space. So there we're using the trim, including the trailing new line that we saw earlier. And to lowercase essentially means that it's going to take out input and just turn it into all lowercase. So if we enter capital R for rock or all caps rock, that capitalization is going to stop mattering because we're turning our text into lowercase. So as string hands the match plain string slice, that's what it's going to use to compare against. And then third, the match itself. So each arm of the match here has a pattern on the left and a result on the right. So the vertical bar is essentially another way of saying or. So rock or the single letter R both produce the some type of rock. The final underscore, again, we're using that as a catch-all or catching anything that we did not list, and this will return none. We're going to lean on option quite a bit here, so getting comfortable with some and none now really pays off. All right, so let's see this in action. So we can actually compare 2 moves as a pair, a tuple, and describe the outcomes directly. So let's write some code for this. All right, so here we're seeing match in action again. So essentially what we're doing is we're putting the 2 moves into a tuple, just written as a pair written in this parentheses. And we're performing match on the pair all at once. So the first arm here, essentially that's going to list the 3 combinations where the player wins. So rock beats scissors, paper beats rock, scissors beat paper. And then reading them as pairs makes the rule of the game line up right here in this arm. The second arm here introduces a new trick called a match guard. So the if that comes after the pattern here. The pattern AB matches any pair and gives the two moves the names A and B, and then the guard. So if A is equal to B, it only accepts it when they are the same, which is a draw. So if I draw paper and the computer draws paper, or chooses paper, sorry, that's going to be a draw. And then finally, we're going to use that underscore again to sweep up everything left over, which by elimination is every way that the player loses. So we never have to type out all of those losing conditions. We can just use the underscore here. Now, because a match must be exhaustive, the compiler checks that we handled every possible pair. So if we forget a case, the program would refuse to compile. So the rules read like plain English, and the compiler guarantees that we didn't miss one, which I think is really powerful. Okay, now we're going to tie it all together in a loop that keeps playing, tracks the score, and lets the player quit. So this is going to be our real main function. So I'm going to get some real estate going here, and let's type out the following. All right, so let's walk through this. So essentially, at the top of our main function, we keep 3 counters. They're all mutable because they can change every round. One for wins, one for losses, and one for draws. The loop keyword starts a loop that runs forever until something breaks out of it. So each time around, we print the prompt and read a new line. If the player type quit, essentially what that's going to do is break the loop. Otherwise, we go down and pass the input. And here the option really shows its power. So if a pass gives us none, we're essentially printing out a gentle note saying, I didn't understand that, and then telling the program to continue, which jumps straight to the next round instead of crashing. If we get a real move, the computer picks one with our random move function, and then we judge the pair down here. So, and then we bump the matching counter. So when if we win, we get the win increments by 1. If we lose, the losses increment by 1. And if we draw, you get the idea. When the loop finally breaks, we print the final tally. So let's open up our terminal again. We'll clear this and run. So it's going to ask us what's our move. So rock, paper, scissors, or we're going to quit. So let's choose rock. The computer chose scissors, so we won this round. So for the next round, let's go ahead and pick paper. And it chose rock, so we won that one again. And then finally, let's go and pick scissors. And it's a draw. Now let's pick something, let's pick the color red. So something not available. It didn't understand that, so it's going to ask us to try again. And then finally quit, and it should print the final score. So we won twice, we didn't lose, and we draw once. So everyone saying that AI is going to take over, I think I've just disproven your point. But there it is. So there's our complete interactive example. So bad input, is handled without a crash. So we're just printing that message. I didn't understand that. Try again. Let's actually run this again. And we'll try our single letter to make sure that works. So R, chose paper, so we lost that. Let's choose P. So, the computer's doing better this time. It heard my comment about AI. So S, it's a draw. If I choose M, again, it's not going to understand that. That's not a valid option. So let me quit out of that. And that time we were less successful. So 2 losses and 1 draw. The revenge of the computer. But anyway, the score's adding up. So every idea we introduce, the enumeration, the option, the match, is doing the real work here. And you can see that we've built a fairly entertaining, workable game. It's very simple. We're at the start of our Rust learning journey in less than 100 lines of code, which is pretty neat. So that's the complete game. So just to wrap this up, we read input, we introduced the idea of getting external libraries or using crates, and we used the rand crate in our game. We modeled our moves. with enumeration, we converted text into a value with option, and we decided the winner with the match keyword. And we also looped while keeping score. All right, so before you move on, make sure that you can tick off the following items. So go ahead, build this game from scratch. This code that we've gone through in this lesson is going to be up on GitHub. The link to that GitHub repository is in the description below, so please check that out alongside other resources as well. So build the game from the ground up. Can build it from a cargo new empty file. And make sure that the game compiles and runs with cargo run. So every time you introduce a new piece of code, make sure it compiles by running cargo run. Make sure that it handles unrecognized input. So rather than letting the program crash, ask the player to try again to try and input some valid input. And maybe you could be a little bit more helpful than I was and be a bit more descriptive in that input message. Now, also make sure you can understand that the loop ends when the player types quit and prints a final score. We didn't implement just typing Q to quit, so maybe that's something you can try. And also make sure that you can explain why the moves are being represented as an enumeration and why pass is returning a option. If you don't know that, go back, rewind the video, and move to that point where, or just re-listen to those two concepts. If you want to take it further, you can add a best of 5 mode that stops after one player reaches 3 wins, or maybe make that configurable. Maybe you want to add Lizard and Spock for a 5-move variant. It's a game. Be creative with it and just get used to writing Rust code in a really creative manner. Now, in our next episode, we're going to slow back down a little bit and we're going to tackle the idea that makes Rust distinctive, and we're going to talk about ownership. It's a really important lesson. It's the foundation for everything else that follows in this series, so it's worth taking your time with. So if you like this video, give it a like. If you want to see that video on ownership and keep following along with the series, please subscribe. If you have any questions, pop them in the comment section below. Thank you so much for listening, and we'll see you in the next one.